All right, we're going to be looking at the last lesson of this chapter 10.5, and really this lesson is just a review of everything we've talked about so far, and it's putting these all together now in problems. So for these problems, you can have any of the factoring we talked about, and a lot of times you're actually going to have to factor several times. So first step you want to do is always factor out the monomials. That's anything that can be divided by all of the terms. After you've checked to see that anything that can be divided by all of them has been factored out, number two is you're going to figure out what type of what type of polynomial you're dealing with. There's a really helpful chart on page 426 that reviews everything we've talked about so far in this chapter, so I'd really check that out. And then you want to keep factoring all the way until the end. So for many of these problems, you can't only factor once. Some of them you have to factor 2 or 3 or 4 times. So after you get your first answer, you will be able to factor again. And then you get your next answer, and then you might have to factor again. So keep checking to make sure you factored completely, which is why this lesson is called Factoring Completely. So the first one we see here, I start off by factoring out my common monomial. So they both can be divided by 5, but they can also both be divided by a and by x. So I'm going to divide this by 5ax and 5ax. That's going to go on the outside. Then I have left, the 5's cancel, the 8's cancel, x to the 5th over x makes x to the 4th. 5a and x cancel, I'm left with y to the 4th. Now I have two things that are being subtracted. Both of them are squares. So I can rewrite this as my a plus b and my a minus b, my conjugates, since it's two things squared. It's x to the 4th, what squared equals x to the 4th? That's x squared, that's my a. What squared equals y to the 4th? That's y squared, that's my b. So remember I have one positive and one negative. But I'm not done. X squared plus y squared, that can't be factored. But x squared minus y squared is the same form as this. These are still both squares. So I can factor again. So I'm going to do that over here. I still have the 5ax on the outside. And I still have the x squared plus y squared at the end. But now I'm going to factor this. So my a is x, because x times x equals x squared. My b is y. So I have plus y and minus y. Now that is my final answer. So you have to keep checking each section to make sure it can't be factored again. Many times you're going to have to factor several times. Here, I first check to see if there's a common monomial. There isn't. There's nothing that can be divided by all three. Next, I check to see if it's one of my special things. This is something squared, but there's nothing squared that equals 8. So I can't use any of my special things. So this is just my basic thing that I talked about in lesson 2. So what I'm going to do, 2 parentheses, and I'm going to ask myself what two numbers multiply together to equal positive 8, add together to equal negative 9. Since this is x to the 4th, I need x squared times x squared to equal that. And then I know that if this is positive and this is negative, they both have to be negative. Because in order for two things to be multiplied together to equal positive and added together to be equal negative, they both have to be negative. So I have negative 8 and negative 1. But I'm not done. I have to check to see if either one of these can be factored. X squared is a perfect square. 8 is not, so that can't be factored. But 1 is a perfect square, so I can factor that. So in the same way I did above, what squared equals x? That's x. What squared equals 1? That's 1. So I have x minus 1 and x plus 1. Now there is nothing left. So that is my final answer. Let's look up here. This time I have 4 terms. So if I have 4 terms, remember I want to group those terms into groups. So I'm going to group these first 2 together and these second 2 together. So these both have an x, so I'm going to factor out my x, and I'm left with 2y minus 7. These both, I can factor out 5, so I'm left with 2y minus 7. Remember, if I have a whole polynomial that's the same in both, 2y minus 7, I can factor that out. And then what I have left is going to be in the other parentheses, x plus 5. I checked, neither one of these are squares. Neither one of them can be factored. So that's my answer, 2y minus 7 times x plus 5. Same thing, I have 4. So when I have 4 different terms, I want to group them. I'm going to group this first group. I can factor out my a. I'm left with m minus n. The second group, I have a p. Since I want it to be m minus n, I'm going to factor out the negative p. That's going to make this positive and this negative, m minus n. Again, same idea. I have an m minus n in both of them. I factor that out, and then I'm left with a minus p. There's no squares, nothing else I can factor, so that is my final answer for that one. A minus p and m minus n. Last one. Again, I have 2 groups, so I can factor. I'm gonna break them up into 2. Factor this side. They both have y squared, so that's going to leave me with 2y plus 5. Both of these have 4. Since this is positive, I'm going to make that negative 4. That's going to leave me with y plus 5. I can, 2y plus 5. I can factor out my 2y plus 5. And then I'm left with y squared minus 4. But I'm not done because these are both squares. So I can factor that as conjugates. What squared equals y squared? That's y. What squared equals 4? That's 2. Now I am completely factored 2y plus 5, y minus 2, and y plus 2. That's my final answer. So the key thing you want to be looking for after you do your first step of factoring is, are there square numbers? If there are numbers that are being squared or that are a square of something, then you can usually factor more after that. So keep factoring until you're for sure cannot factor anything else. That's what it means to factor completely.